Thank you very much. This is the agenda. We have 15 minutes. We have started 15 minutes late, so we are going to be quickly to be on time. Okay, we are going to a little introduction, a background about Jidoka, a little introduction to what is robotic process automation, how fits RPA with machine learning. Victor Diaz will explain in detail the business case, the two business cases around RPA and machine learning. First of all, Jidoka. First of all, Novaire. Novaire is a company that we founded 11 years ago. It's very close of here. We have the headquarters very close. We born in Sevilla, in Spain. We have 30 people that is over 20 years of experience in IT and business consulting. And we have 4 offices. We have one in Seville, one in Madrid, one in Colombia, and last 6 months ago we opened the London office. And what is Jidoka? Jidoka is a Japanese term that's meaning automation with a human touch. This came from lean manufacturing, and this is a platform for developing, implementing, and orchestrating robot software. Now we are going to explain later what is a robot software. We have a good presence in analysts. And you know that analysts move the world. So we have a good presence in Gartner as a representative vendor. We are the only Spain and Latin vendor that is in Gartner, HFS, Everest Group as a major contender. And we have a global partnership and global alliance, especially focusing in Spain and Latin. No? We have from Big Four like Deloitte, KPMG, Deloitte Spain, KPMG in Colombia, Indra, Accenture. We have a small and niche player, a niche consulting firm from Mexico, like WO, SEA in Costa Rica. We have in Chile good partnerships, and we have good customers. No? We have 40 good brands, 40 good customers from banking, like EBO, like we think, from utilities, from BPO, PepsiCo in Latin, Aeromexico in aerospace. We have good branding, we have good partners, and we have good partnership with BigML. We have a close relation with the BigML team, and we have a good partnership. You need partners for implementing and develop robots, and you need partners to complement your technology, and this is why we partnership with BigML. What is RPA? What is robotic process automation? I always start my presentations talking about what is the challenge for what we are calling right now the digital transformation of the company. There are a lot of hype about digital transformation. There are a lot of people talking about transition to digital products and service, mobile, cross-platform, new systems, blockchain, fintech, regulation, big data. And I think the first step of the real transformation of the company is operation efficiency. It's the need to optimize the front and back office, reducing costs and ensuring quality of service and process. And this technology, any technology that reduces costs, especially staff-related costs, and improve process, ensuring the quality of the service, become a competitive advantage for any company that would like to do a real transformation of their business. So RPA, that's called robotics, also is called robotic process automation, responds to the needs for reduced human intervention. You need to think your company, you need to split your company between digital workforce and human workforce. Digital, that is about repeatable, high volume, and well-defined tasks, that is robotics tasks, and humanistic tasks, skill, judgment, and empathy-based activities, that is the human workforce in your company. So what is a software robot? First of all, it's not a physical robot. No? It's a program, it's a software. It's a program that mimics what the human do in front of a computer. It's use application in the same way that people do. Using the user interface, reading and entering data and screen, move the mouse, use the keystrokes. It's use the system the same way that the human do. And this technique is not intrusive. Jidoka and RPA not modify the application. They use, I always like to say that it's like a macro in Excel. It's similar like a macro in Excel. They don't use and they don't modify the application that they are using. This is automate tasks. You don't need to automate the end-to-end process, but it's better if you automate the end-to-end process. So it's possible to combine RPA with BPM or with machine learning. No? It's true that you need to think with more strategic approach. No? This technology more like a tactical approach, but it's better to think like a strategic and end-to-end approach. One of the difference with other technologies is the return of investment, because this project is available in weeks or in months. No, it's not about AI integration, BPM integration that is months or years. This is only weeks or months to automate an end-to-end process using RPA. It adapts to changing scenarios. For example, we have a component that is called Hockey that recognizes text and image on a screen, even if they change the positions of it, they don't renderize in the same way. So this technique and this Jidoka is adapt to changing scenarios. And finally, software robots reduce manual intervention, so the humans can focus on activities that require cognitive interpretation. How fits machine learning with RPA? Now, what RPA wins for machine learning? First of all, analysis of unstructured documents and connection between doing and thinking. No? The software robots is not smart robots, it's not learning robots. They can learn, they can think, and machine learning can improve our way of intelligent robots in our platform. This is what machine learning wins for or fits with RPA. And what we do for machine learning, first of all, the connection with any system to extract any information. No? You need data. You need data for the algorithms. If you don't have one API to connect to any system, you can, and you need to use robotics to extract any information. And the second is to perform actions after execution of the algorithms. The algorithms execute, and who is going to do what the machine learning says. This is better to do by robots than the human. No? Typical tasks for RPAs, opening emails, copy-paste, entering information into system, logging and log out is not very smart task. But in typical tasks is clustering, classification, regression. This is a typical task of machine learning, like we have seen this morning. For application example, for example, customer support, machine learning identify a customer request, understand the emotion of a solution, and triggers backend process through RPA for quick implementation. The second is is the loan process management. RPA gets the collection of the correct financial information, machine learning models the loan approval process, and recommend interest rate. No? The RPA gets the collection and extract information, and machine learning apply the approval process. Documentation. There are a lot of use cases using RPA with SharePoint, with SAP. No? Or, for example, to get the requirement of complex process about documentation is a good example of using RPA. And the last one is a use case that we are going to show, this ticket routing for a technical help desk. There are thousands of hours in the technical help desk, and RPA take the ticket description from Siebel, from ServiceNow, and call to machine learning prediction to fetch the routing information and to continue to automation process. This is some application example in different scope. So, Victor, it's your turn.
Okay. Thank you. Thank you, Victor. This is working? Yes. Well, I would like to share with you a couple of examples that will show the powerful synergies between RPA and machine learning. The first one is a process that we found in a department of mobility of a town hall. And this department is going through a process of digital transformation. And through the process, they found that they need to translate a scanned document and to put the relevant information from those documents into the database. So that's the goal of the process. That's the goal of the automation, to transform an image into some kind of structured information that can go into a database. So in this process, we have well-defined and repetitive process, so all the actions are very well defined. We know what we have to do, and that's the first thing that we need in order to automate it with software robots. Then we have a very high volume of transactions. We're talking about tens of thousands of documents. So that makes worth to create a robot that automates all this. Because this is a labor that is very time-consuming and is also error-prone. If humans have to type all the information into the database, it's a very error-prone process. So everything is makes us think that this is a good example of RPA, but there is a problem. And the problem is that in the document we have a handwritten number, and currently RPA is not able to read that number by itself. We cannot read handwritten numbers. So we need the help of machine learning. We need the help of BigML. Okay. So this is an example. We can see, later we will see a clearer example with all the data. Here we can see that we have to extract the information, both printed data, like the name, the address, and also the handwritten data. We will see later a clearer example. Okay, so in order to do that, we can reach so far with the Jidoka robots, because the Jidoka robots has an integration with Tesseract that is arguably the most powerful open source OCR engine. So technically, if the quality of the image is good enough, that part is solved, okay? The part of reading printed data with an OCR is already solved. But in order to read the handwritten data, we need, first of all, to use OpenCV to process that image and to locate where is the number that we want to read and to clean the image and everything. And then with that image, we can transform that into numbers, into data that BigML is able to process. Okay. Here we have the example. In orange, we can see the printed data that we want to extract with OCR. It's like, I don't know, the date, the name, the address, everything. And in the green box, we can see the number that we want to read. So what we did with OpenCV is to locate that number, and we decompose the number into several digits. And we transform those digits, those draws, into a matrix of numbers that represent the morphology of the number. So actually, what we are using BigML for is with a deep net, we are predicting the number written using a matrix of numbers that represents its morphology. Okay, as we can see here, BigML did a very good job, and the probability of this particular number is higher than 90%. Okay. 90% is like the limit we like to use. If the probability of success, if the confidence of success is higher than 90%, we say that it's an okay. But if the probability is lower, we discard the item because it's not enough, the probability is not enough for us. Okay, so that's one example. And now we can see another example is an email classification. In this case, what we have is a large company with a customer service department that receives a lot of emails on a daily basis, and they want to create a task for a certain department to address that mail, to solve that problem or to answer that question. And they are doing this manually with humans right now, but they wanted to see if a robot could improve the process, okay? So in this case, our goal is to make the process more agile and more responsive and to do it faster, okay? So again, we have a process with the same characteristics that we saw before. It's a well-defined process with high volume of transactions, and everything is okay for us. But again, we have another problem that we cannot solve, and that's the case of unstructured text, because we cannot process with RPA alone. We cannot process natural language. So we need BigML to tell us, giving them the body of the mail and the from and all the data from the mail, which department BigML thinks that is more suitable for answering that mail. And that's what we use it for. Here we can see an example of a typical workflow for a Jidoka robot, for a software robot. First of all, well, in orange, we can see all the actions that we can do with RPA technology. We can do a lot of things with RPA technology, as Victor said before. But in green, we see that predict the department is the only part that we need machine learning for. So basically what we do is we check if there are new emails in the inbox. And if there are, we open the ticket application where we're going to create the task. And then as long as we have new emails to process, we extract the data from the email, and we use BigML to predict the department. Then with that department, that prediction, we create a ticket and we assign the ticket to the right department. Okay, and then in the end, we just close the application. So here's with a little more detail. I'm going fast because we don't have much time. But I want to point out that there are a lot of things that Jidoka robots can do, like communicate with a lot of protocols, like SMTP for emails or FTP for files, a lot of protocols. We can integrate with operating systems, so we can open and close and manipulate windows and pass buttons. All those things we can do. We have all the power of Java language because Jidoka robots are developed in Java. So we have all the power of this language and all the libraries in order to do a lot of process. But what we cannot do is, as we saw, predict the department because we cannot process natural language. So we've trained a model, and we've used the Java API that BigML offers. So the robot integrates directly with the API, so it's able to use the model to predict the department. Here we can see, I'm going very fast here because you already know. If it's been explained before, much more better than I can do. So this is our source file. We have the from, the to, the subject, and the body. And because it's a model that is supervised, we need the department. We need to teach the model which department is the right one. We have data because this process has been doing before by humans, so we have all this data. So based on this data, we've created a data set, and we've generated a model. In this case, is a decision tree, the model that we use, and we've trained the model in order to make it more efficient, okay, and to ensure higher accuracy. And with this, again, we've used the model to predict the department. And as we did in the previous case, if the probability, if the confidence of the result is lower than 90%, we just assign that, email to an unknown department. So a human will have to check it later and solve it by themselves. And with this process, we have achieved a very high success. We've reduced the manual intervention, and we've reduced the response time, and overall, we've optimized the process. So the client is happy with this. Now, I would like to show you a quick summary of this last example that I've just explained with a little video that is going to show you. Hopefully, this is going to work. Yes, it's going to work. Okay, so now you want to talk?
Okay. Yes, now we are on time. Thank you very much. The last one is about what is the intelligent automation for us. No? We see RPA as the base of a pyramid that is to automate the 70% of the tasks that the human do in front of the computer, but is repetitive and well-defined tasks. And you can apply machine learning, you can apply chatbots, you can apply artificial intelligence at the top of this pyramid. But it's true that if you want to best result from AI, you need to ask a human. This is an interesting post of mid-review. I recommend to read. And finally, you may say that RPA is the arms and legs, and the machine learning component is the brain of intelligent automation. Okay. Thank you very much.